Good morning everyone. In today's class is about the introduction part of your unit 4 that consists of your insulators, that is in overhead lines and also the cables. Today we are going to discuss about the insulator topic, which is the second half of your 4th unit. Insulators you might have seen in the transmission line towers in order to produce clearance between the transmission line and the tower and the transmission line. The insulators have been situated in the cross arm. The cross arm is nothing but this is the tower construction, means the arm which is extending from the tower is called as the cross arm. In that cross arm the insulators are imposed, that is maybe of pin or post. So far we have this we will discuss about what are the types of the insulator that is being used in the transmission system and why those insulators are used. They were bare and they are not covered with anything, and insulator is mainly used for the clearance purpose of the transmission line and the tower. Tower is a metal part, and in order to produce the clearance they are using insulators. These insulators are made up of mainly of two kinds. One, it is glass material and another one is porcelain material. The glass material we can shape it of whatever the shape we want, and we can also, it is the main advantage of using glass materials, it is cheaper too, but we can visualize what are the internal damages visually. So this is one of the good advantage, but when compared to the absorption of moisture, glass materials play a poor role. So we are going for the porcelain material. Porcelain material is the mixture of plastic clay. These material you might have seen in the transmission system is a brownish material that is hanged over in the cross arm and a pole in the street, and this porcelain material made insulators are somewhat good efficiently when in the part of absorb the moisture, which is the disadvantage in the glass type of insulators, and it won't absorb the moisture, and the shape can be in order to produce the shape, particular shape which is a very not an easy process, which is difficult. But the main thing of going for the porcelain material rather than glass material is the absorption of moisture during the bad weather conditions. So what are the types of insulators we are going to see, and the main factor we are going to discuss about in the insulators will be the string efficiency. So when two parallel plates are acting and in between the dielectric medium will present, we will act as a capacitance. The same concept is going for also the transmission line and in the cross arm, where the metal part and the transmission line is considered as the two metallic plates, and between the air as a medium, so it is considered as a capacitor. Even though it is an insulator, the term of one insulator will calculate it as a capacitance. And what is the total string efficiency, and what is string efficiency, formula, and how we can calculate for a given cross arm with number of insulators in a particular arrangement. This is what we are going to discuss about in the insulators. So first, if this is the transmission line tower, you have seen some cross arms were projecting outside of the surface. In this surface, they have mounted the insulator, which is somewhat brown color. If it is brown, it is made up of the porcelain material. So what is the type of the insulator? The type of the insulators are, first one is pin type, second one is post, strain, and suspension. These are the four types of insulators that we are going to discuss about. I mentioned the cross arm is this part of the transmission tower. Cross arm is this region, and this is the insulator, series of insulator connected, and this is the transmission line. In our pole, in the street pole, you might have seen there is a wooden block or a metal, and in this insulator will be there. Here a groove will be there. In this groove the transmission line is placed. So I have set the my insulator is placed to maintain the clearance. So for the clearance of this metal part and this metal part, the insulator is being placed. So for an insulator we will calculate as the capacitance acting between two metallic parts. With this we are going to calculate the string efficiency. This is about the introduction, and now we are going for the types of the insulator. The first one is pin insulator. So the pin insulator will typically be like so pin insulator more or less will be like this. So why this curvature and why this arrangement is to not to stagnate the rainwater, because of the porcelain material. Even though if rain is there, the dry part of the inside material of the porcelain will act as a good insulator. And the next point is the pin insulator is used for less than 33 kVs, and in the top of the pin insulator there is a impression like this. So in this the conductor is passed. This is the transmission line conductor. In this groove, so groove will be like this, and the conductor is passed till the part of the insulation material. This conductor is surrounded by a spool tie material. If this is the conductor part, and this is the part where the pin type insulator is having the projection. So above this the conductor is passing through. So till the position from the starting and the ending of the insulator, we surrounded the transmission line conductor with the rubber type material called as the spool type in order to prevent the clearance and in order to prevent the touching of both the insulator and the conductor. So we are preventing with the another insulator that is called as the spool tie. We placed a spool tie here, and the dimension is all about, it is about 278 millimeter, and the height is barely 242 millimeter. It is made up, and the pin is a soft metal, and the thimble is used. The adequate path of the two most important path is the condensation and the leakage path. For the condensation during the rainy season, the shape of the pin insulator is made like this, so that the dry, as I have told, so the dry part will do the condensation, and due to this dry part, the leakage path is obtained. So the next type of the insulator is the suspension type insulator. The suspension type insulator is advanced to the pin insulator, but it has the series of connections, but it is disc shaped. It is disc shaped, and it is mounted one above another in order to achieve the preferred voltage. For the higher voltages, in order to maintain for the pin insulator, to provide these regions, these shape of the pin insulator is called as the petticoats, to provide these petticoat for the porcelain material, because as I have already told, the structuring of the porcelain material is difficult. So for the higher voltages, to provide more petticoats and leakage for condensation and leakage purposes, to maintain the insulator like this, it is difficult. So we are going for the suspension type insulators. In the suspension type insulators, these one of the insulator is made for the very low voltage, say it is 11 kV, and if we tied and if we keep on tying the same voltage level insulator at a 3 or 4 number, we can achieve the desired voltage level without spending more time on the difficulty of the posture. So this type of insulator, they have a groove under each insulator. In this, the transmission line is passing through. So as it is named called the suspension, since the transmission line is suspended in these insulators. So in the above part, it has the metal part, and the metal part is connected with the clinch, and it is connected to the another insulators. So by this, the series of insulator is connected to achieve the voltage level. So by connecting with the metal clinch, the whole of the suspension type insulator is very flexible. So due to its flexibility, the voltage stresses will be reduced. It is if one of the insulation is in the problem and we have to replace another insulator, means easily we can insulate one of the insulating material with the series of the insulator. So it can't affect the whole system. So for the suspension type insulator, the main advantages, first one, for low voltages we are manufacturing the insulators. By the series of connection we can achieve it as for the high voltage, not for one particular insulator is defined for the high voltage. So there is a series of low voltage in which insulator which is connected in series to achieve the high voltage. Second one, it is the flexible when compared to the pin type insulator. Due to this flexibility, voltage stresses will be reduced. And third one is the increased number of discs during fault. Third one is during fault conditions. If there is a fault conditions and we will remove the one of the insulator, and if we want to increase the voltage level, we can simply add up 3 or more insulator to meet up the higher voltages. These are the 3 main advantages when for the suspension type insulator when compared to the pin type. Next one is the post type insulators or the advancement of pin insulator with higher voltage levels. So these are used for supporting the bus bars and disconnecting switches in the substations. So the voltage level for this post type is the 400 kV, and polycon post insulators, it is also called as the it is used for polycon post insulator, and it is also called as the multi-cone insulator, since if the insulator is here, they are cemented by another insulator same as the suspension type, but the position will be of the pin insulator. If the 2 or more pin insulator are connected with each other, that will form one of the post insulator. If this is one of the post insulator. See, the structure we are having is similar to that of the pin insulator. For a higher voltage level, we have maintained like this. So this is the disadvantages for going for the suspension type of insulator. But this is not an easy job to maintain this posture for the petticoats. But for higher voltage level, this is maintained. For even for higher voltage level, we can simply add the insulator above, because the projection is given here. We can cemented the voltage here, or we can groove with the lower part of another insulator with the upper part. And the transmission line system is like the suspension type, it is suspended below the insulators. And another type of the insulator is the strain insulator. These type of insulator is mainly used for the strong suspension. If the transmission line tower goes along the straight direction, and suddenly if the direction changes, in order to maintain the voltage stresses to change the direction, the strain type of insulator is used. Suspension type is, I have told you, it is in the vertical direction. For strain insulators, it is in the horizontal direction. If transmission line is there, the insulator positions will be like this. This is for the crossing the rivers. And if the transmission line becomes, if these two transmission line are straight, my insulation will be like this. My insulation will be like this. These type of vertical clinging of insulators is used for when the distance of the when the direction of the transmission line systems changes, and in order to maintain the voltage stresses, these type of vertical arrangement of insulators is used, and the insulator used in this vertical positioning is called as the strain insulator. So far we have discussed the 4 type of insulator, that is pin, post, strain and suspension. Now we are going for what is string efficiency. String efficiency, this is the important term in the calculating the in the calculation part. So first, this is my tower. So for calculation, this is my tower, and cross arm will be there, and cross arm I will put insulators will be like this, and below the insulator my transmission line system is there. So for electrical equivalent, so this is my transmission line tower, and this is my cross arm, and this is the cross arm. And as I have told you, each insulator I am considering it as the capacitance. So here I am having insulator number 1. Okay, so that will keep on increasing to insulator number n. Similarly, n plus 1. Similarly, it goes on increasing till the end of the line. So why I am insisting a capacitance here? So this is the metal part, and below the insulator is also the metal part is there. So between these two I am adding the capacitance, because two metal plates conductor and air as a dielectric medium, it will act as a capacitance. So I am including the capacitance here. Similarly for another insulator, and till it reaches the transmission line system. And another important point we have to note is the transmission line tower is also a metal part, and here is also the metal part is having. So between these two another capacitance will act. So this capacitance, if I am taking this capacitance as C, and voltage across this insulator and the cross arm is V1, and this capacitance will be K into C, where K is the constant which is not more than 0.1 and 0.2, that is between 0.1 and 2. Similarly here I am having another KC. So the idea is cross arm point, metal conductor point of the insulator, a capacitance will be there. With this metal point and the transmission line tower, another capacitance will be there. If this is C, this is KC, K is 0.1 to 0.2. So string efficiency formula, what is the formula for string efficiency is total voltage across the string. If I consider this as the string of insulators is carrying the transmission line conductor placed on the cross arm, the total voltage across the string divided by total number of insulators into voltage across the lowermost ring. If this voltage I have calculated as Vm, suppose n into Vm, so V1 plus etc. to Vm divided by n into Vm is the string efficiency. So this is the tower cross arm, and this is the series as this is the diagram we have drawn before. This is the first insulator and connected to this, and this is the insulator with capacitance C, C, C and C, and here it will be KC, KC and KC. So starting from the first insulator, this is my nth insulator, so the voltage across this will be Vn, and with the capacitance C, and here the capacitance Kc and Kc to the cross arm and the metal part of the point between the insulator, and this is my voltage n plus 1. Up to this it is n, this is n plus 1. For calculating I have written it as V1, Vn, Vn plus 1. So the current is drawn from the line in this direction if this is the suspension type. So the current here will be In plus 1, and here the current is In. So this is the current I have differentiated In. So by KCL, In plus 1 equal to capital In plus small in. So we all know that the current in the capacitance, current in terms of capacitance is the voltage into j omega c. So substituting this for the particular voltage and the capacitance value, In plus 1 is across passing through the capacitance C, so it is j omega c, but the voltage is Vn plus 1. So Vn plus 1 into j omega c plus what is In? Capital In is the capacitance is Kc and the voltage is V, not V. If which is equal to here capital IN, the capacitance is Kc. In order to determine the voltage here, I have to summarize all the voltages above this point. So above this point I am having voltage Vn, Ven minus 1 that goes up to V1. So in order to calculate voltage at a particular voltage at the voltage between the tower and the insulator point, we have to summarize the voltage above all the insulators. So above this insulator I am having the number of insulator connected in series. So all these voltages in addition will be V1 plus V2 plus V3 plus etc. to Vn into, this is the voltage, and j omega into k into c. So for calculating a particular voltage between the cross arm and the metal point between the insulator, we have to add all those voltage that is present above the type of the insulator. Then the next one is the small in. The small in is here. So small in, the voltage is Vn into j omega, the capacitance is C. So simplifying this, I am taking j omega C as common. So this will be V1 plus V2 etc. to V. Here it is Vn, here it is Vn. So I am taking Vn out. So it will be Vn minus 1 into j omega I have taken out into k plus the voltage at the nth voltage into 1 plus k. I have taken Vn, so it is Vn minus 1, and combining these V2 Vn, it will be Vn into 1 plus k. So if this string efficiency, if I want to calculate the string efficiency and it is not uniform, what I have to do? I want the string efficiency should be uniform. So for non-uniform string efficiency is what I don't needed. Non-uniform string efficiency is not I needed. So there are three methods to improve the string efficiency. These three methods are used to improve the string efficiency. Why I am improving the string efficiency? It will directly plays a major part in the efficiency of the total transmission system. That's why I want to improve the string efficiency. So how can I, before going for how to improve the string efficiency, I have to understand the fact that the units nearest to the lines, are stressed to their maximum allowable value to those when compared to the tower end. So here I have to put maximum insulation, then I have to put near the insulation near the cross arm. Understood? Because here there will be, the stress will be in the maximum point when compared to the upper region, because the line voltage, transmission line voltage is nearer to this point. So there, at this point only the maximum stress will be there. So but practically what we have thinking is to reduce the stress between the line. Here the voltage insulator is of a size, when going to the tower end the insulator size may be less, but that is not easy. But we don't have different type of insulators. As I have already told, molding of insulators will be very tough, and for the faulty condition and for increasing the voltage level, we are placing the insulator of a particular dimension. So this is a bad idea for changing the dimension. So what else we have to do to maintain the capacitance all over from the cross arm to the line is to be equal to get a normal string efficiency. So to improve the string efficiency, the three methods are reducing the shunt capacitance. First type is the reducing shunt capacitance. So what is the shunt capacitance mean? With the capacitance that is acted between the metal part of between two insulators and the tower. So this can be done only by increasing the length of the cross arm. So reduce the shunt capacitance, I have to increase the length of the cross arm. So this cannot be applied, because we have already know that this Kc value, this K value should be 0.1 to 0.2. This is the must value to be maintained. If we increase the length of the cross arm, this constant shall not be maintained, so it will affect similar other factors, so it is not a good idea. So the second one is the capacitance grading. Capacitance grading, this capacitance grading means increasing the capacitance of each unit from the tower end to the line end. We are increasing the capacitance from the tower end to the line end. Theoretically, voltage across different units can be made exactly equal to the capacitance, but implying this, the insulator disc size will be different from one another. As I have told before, grading the capacitance means we have totalizing this capacitance from cross arm to the line to make it as similar, but doing this, the insulator sizes will be different for different capacitance. So this is also is not a good point. And the third one is the static shielding. Static shielding is to improve the string efficiency by providing a static improving the static capacitance. So this is my cross arm. So what is static shielding is, this is my cross arm and this is the capacitance is there. So in this method, the large metal ring surrounded at the bottom unit. So here this is my line. So large metal ring that is surrounded at the bottom unit is used, and it is like this. Now these two parts will have a capacitance, right? These two parts will have the capacitance. If the current from this point is equal to, if this is my IN dash and this is IN and this is IN plus 1, if I am having the string here like this, which is suspended like this, I hope you understand, this string like this which is suspended like this, here I am having the capacitance. Now the current from this capacitance will be in this direction. If this IN dash is equal to IN, here it is IN dash, so this IN dash, here the current is IN. So IN dash equal to IN, then IN is equal to IN plus 1. This IN is equal to IN plus 1. So if by maintaining this, voltage across the N and N plus 1 will be equal. Even though we can adjust the shape of the ring, so the distance between this point and this point is higher when compared to these 2 points. So the capacitance will be compensated for the region where we don't want the capacitance much more because of the reduced stresses. Here we have much stress, so the capacitance here are placed very nearer to the cross arm and the insulator type and the insulator to the metal ring. So here the total capacitance, if these current are equal, then the voltage across these capacitance will be equal. So it will provide a considerable improvement, and still it needs some improvisation in the total string efficiency factor. The main thing you have to understood about the string efficiency factor, you can understood from the problem. So from the given problem, as we have discussed, I have drawn the cross arm and the tower and the cross arm and the capacitance between the lines, and we will distinguish this voltage as V1 and this is the V2 and this part is V3 and this one is the V4. Now my ultimate aim is to calculate string efficiency. So for string efficiency, I need the formula is voltage across the string. What is the voltage across the string is V1, V2, V3 plus V4 divided by number of insulator is 1, 2, 3, 4. 4 into voltage across the lowermost, which is nearer to the line end, that is V4. So this is the formula for the string efficiency. For this I have to need V1, V2, V3 and V4. We already know if we take the K as 0.1, now here I am taking the K as 0.1. So this is 0.1C, 0.1C, 0.1C. No other data is needed. So this is the main data we have seen, and I have denoted this junction P, junction Q and junction R, P, Q and R. With this junction applying KVL, we are going to find the string efficiency. That is our ultimate aim. So P is equal to, at junction P, applying Kirchhoff current law, for current law I should have the capacitance voltage. So at junction P, this voltage is V2 with C. So C V2 into J, I am neglecting. So omega C2, which is equal to, what is the voltage here? It is omega C V1 plus 0.1 omega 0.1 C V1. So I am taking this voltage for this particular voltage. For this voltage, I have to add the sum of the voltage above the insulator. So the what is the voltage here is the V1. So simplifying this, V2 is equal, omega C can be cancelled. V2 is equal to 1.1 V1. So at the junction Q, I am applying this. So this is C into V3. So C into V3, cancelling J omega. So C into V3, the voltage at this point will be C into V2 plus voltage across this is omega 0.1 C. I am taking constant. V1 and V2 is there. So V1 plus V2. Simplifying this, I am getting V1 is equal to 1.31. Sorry, V3 is equal to, V3 is here, V3 is equal to 1.3 V1. Similarly, I am going for R. So this is the R, V4 is there. So C into V4 is equal to, voltage of this point is C into V3 plus 0.1 C. I am taking as constant. V2, V3, V1. V1 plus V2 plus V3. So simplifying R, I am getting V4 is equal to 1.651 V1. So if V1 plus V2, from if this is the 66 kV line, 66 kV line, so V1, V2 plus V3 plus V4 is equal to, if this is 66 kV, I am taking the line voltage into root 3, which is equal to around 38.1. I know what is V2 in terms of V1, V3 in terms of V1 and V4 in terms of V1. Substituting these 3 points in this equation, I am getting V1 as 7.53 kilovolt, and similarly for V2 and V3, V2 is around 9.86 and V3 is around same as that of the 9.86, and V4 is 12.43. So from this P, Q and R, I have obtained all the 4 values of V1, V2 and V3, V4. For the string efficiency, I need all these voltages. I have obtained all these voltages. So V1 plus V2 plus V3 plus V4 divided by 4 into V4. So V1 plus V2 plus V3 plus V4 is, here what we have calculated is 38.1, and for V4 is 12.43. So 4 into 12.43, which is equal to 0.766, or it is 76%. For a 66 kVA line with 4 insulators that is connected to the cross arm, the string efficiency is 76%. If this efficiency is not sufficient and we want to improve the string efficiency, we are going for 3 methods. That is the reduction of the reduction in shunt capacitance grading, that is increasing this capacitance, and the third type is the static shielding, that is reducing the static capacitance with the metal ring that is connected from below the part of the string. So far we have discussed about the insulators. The type of insulators is pin, post, strain and suspension type, and where we are using this and what are the voltage level we have discussed. That is the main basic point to be discussed here. Next we have seen what is string efficiency. what is the formula for string efficiency? Is the total voltage of the string when it is when a string of insulator is considered, the total voltage across the string divided by the total number of insulators and multiplied with the lowest insulator type. So maintain the string efficiency, we are going for what are the methods to improve the efficiency, and these are the points we have discussed about the insulator. This is the first one of the half part of the 4th unit, and in the next class we will discuss about what is cable, type of cables, and the methods that is used for the cable grading. So thank you.